ideally, if we can guess things, we would like to start at VDD and end at VDD or out, or يعني, if we pass it. Okay, so I will explain this. So ideally, given any circuit, okay, in this circuit, if the loop passes throughout only once, okay, إذا بنقطع بالoutput once, ساعتها this means that the capacitance of the output is not much لأنه it's a shared diffusion. يعني هو what you can think of is that when I draw this loop here, for example, in this scenario بلشت BDAC and I have my poly, and if I look at the stretch of the PMOS, okay, this stretch of the PMOS from node 2 to out to VDD to the intermediate node 3, then to VDD, okay, then to 2. هيدي stretch اللي هي هيك flat line, it is really this curved line here, right? So you can envision that I took this line, I held my hands on this end and on this end, and I flattened it, okay? So if the Euler path is simple, and it is one cycle, then it would be easy for me to guess, yes, here I am going to have the output one diffusion in P, have one diffusion in P, oh no, 2 has 2 diffusions in P. Maybe for this scenario, it would have been better if we restarted this and said, well, since the VDD and the ground typically are ideal, and who yesterday a friend of yours asked this question, and do I look at the parasitics at the ground node, and نحن if we look really the substrate or the wafer كلها محل ما transistors عم ينزرعوا as transistors, okay, where I have my transistor areas plotted يعني, okay, the different transistors occupy substrate, it represents the body, and the body is grounded. Okay, so any metal wire that is also connected to ground, any metal wire فوق بلاير فوق that is connected to ground, فعليا كأنه أنا عم طلع على الكاباسيتنس بين ground و ground. هيدي مثل resistor من short to short ما بيأثروا. So a capacitor from ground to ground منه مشكلة عندي. Okay, in a similar way بما أنه الأنوال is connected to VDD, and since VDD is also considered a DC signal, which is strong, we typically do not calculate the parasitics بين VDD و ground أو بين ground و ground. We ignore them. هلا there is much more in-depth analysis here. I don't want you to worry about it. بس بدي إياكم تفكروا إنه مثل ما كنا ندرس small signal analysis بال 311. أنا VDD و ground ما بدرس عليهم parasitics. So in this scenario, the stretch, instead of it being like this, for example, this stretch, well, I can think of it being starting from VDD and ending at VDD, or starting from ground and ending at ground. ساعتها the repeated node will be ground in this simple example, and I only count the output twice. طبعا إذا structure للgates are more complex, then it will become more like trial and error. Unless we have an algorithm that can go over all the possible Euler paths, يعني نصير عم نشتغل بgraph algorithms, then I can find the optimal one based on my specific criteria. يعني I have to know what are my criteria. Okay. Anybody has any other questions? طيب, so هلا we will have then we will continue with the examples, and I will post those slides online for the scratch ones. In here, if you want to look at the stick diagram, this is how a fancy stick diagram will look like. بس نحن اتفقنا انه بنحط P, بنحط N, ونرسم البولي بالريد for you, يعني for your own vision, and in here we will have VDD and ground. طيب هيدا أخذ الأوردر. What order did this guy take? He took A, B, D, C. So it's clear ليقدر يمشي من A ل B ل D C. طلع هون ومن هون أخذها وبده يبلش هيك A, B, D, C. يعني كمان أنا I have another constraint which is the euler path has to be in the same order to maintain my poly in this clean and clear fashion. So إذا بدي ألحقه أنا enumerate the nodes if I want to follow him and enumerate the nodes, A will start from VDD. Okay, then it will go, we will visit A, we will go to node 2 here, if we call this 2. Then we will go to B, we will hit the output, okay, which is here, we will revisit D, we will visit node 3, okay, and then I go back to VDD. هلا بالان stretch إذا بدي أجي أطلع عليها أنا ببلش من node 1. Well, in the end stretch, pardon me, he started from A, let us see. Yeah, I start from node 1. Then I go down until على the ground, so this is the ground here. Then I continue back to B and visit node 1 again. And then I continue back to the output, وهيدي هي الout. And then I go back to C and I visit node 1 again. طبعا بهالحالة 1 has to be connected, so عندي 3 diffusions اللي هن CN. هلا later as we will see, as you see in the homeworks, نحن عم نقول إنه WN هو W و WP هو 2W and the capacitor C هو some constant times the width of the device. يعني للأنموس هو CD ضرب W وللبيموس الكاباسيتنس حيكون بيساوي 2CD ضرب W. هيدي terminology لأنه نحن we can calculate the diffusion capacitance for a specific width لأنه هو عنده certain dimensions and we can use it accordingly. Okay. So حسب الويدث بيكبر الكاباسيتنس لأنه الاريا عم تكبر. Okay. طب هلا we are going now to look at this example. Here in this example they are trying to demonstrate to me أنه أنا the same equation F, depending on how I draw it, I might be able or not be able to find a Euler path. يعني هون the uniqueness of A, let us see, let us try to find a Euler path, and why don't you take 1 minute and try to see if you can find a Euler path. Okay, let us see if you can find a Euler path. هات لنشوف. إذا نزلنا نزول the best way طبعا إنه to finish all the route and to come back. So this would be A, B, D, E, C بالtop part, and بالlower part I'm stuck لأنه أنا بدي أروح عند A, B ما فيني D, E, C بدي أخذ هيدي stretch separate لأنه بدي أعمل cut هون صح؟ طيب if I start with the lower part, let us see. If I start with the lower part and I try to make a path اللي هو A, B, C, then take this path D, E. So this would give me A, B, C, D, E. The problem that I am getting stuck with is I have to visit this. I have to visit the two that are in the loop. يعني ال BC عم يصيروا BC parallel. مجبورة ألحقهم. And so then I cannot visit D and E except in a separate loop. ولا بصير بدي أعيد C twice, which is not allowed, which is not efficient for me and not allowed. Right? So the placement of A in the top forced me إنه I have to visit this loop and then I'm stuck. I cannot visit the other one if I want to do like this. So let us see another topology, okay, where we placed A in the middle. ليش هاي هيك؟ هلا أول شي نطلع to refresh the circuit. How we build the circuit? Y is equal to BC or A or DE bar. DE كلها سوا بار. يعني للpull down أنا عندي A in parallel مع BC هو inner loops وعندي DE in series in parallel مع BC in series in parallel مع A in series لأن هون الثلاثة blocks اللي عندي هنا. Okay, and in the pull up I have B and C in parallel بالpull up وعندي D and E بصيروا in parallel, but I can place A in series with them wherever I want. صح؟ يعني the order of ما هي هاي بتصير BC parallel بالأنموس ل A parallel ل DE وهيدول هن in series وبالبيموس بنقلبها بتصير B parallel ل C in series مع A in series مع D parallel ل A. Okay. هلا the series is interchangeable. I can place A on top, I can place it in the middle, it doesn't matter. Now when I have this scenario, okay, of course I cannot create the Euler path يكون هيك لأنه بتبقى C لحالها. So how do I want to create my Euler path? Anybody can guess?
فينا نبلش من ال ED نطلع على ال BC.
صح. So بدي بلش من هيدي النود لأرجع to visit the A لفة أو بلش من السي BA أرجع على D. صح؟ Whichever we want to pick as our starting point. So it will be E, D, A, B, C. And if I want to follow the same, it will be E, D, A, B, C. Okay? So this works for me in all directions. بالpull up
بروفيسور بتطلع سي بي تحت.
ايه ساعتها انا بدي اكتب السيركت بي سي. صح؟ اوكي. يعني بدي اكتب التوبولوجي. هلا اذا انا جبرتكم بهالطريقه من الانبوت لا، بس اذا انتم عندكم الفانكشن يو ار allowed. اذا بدنا نلحق هيدا السيركت هيك لنشوف if we can do it otherwise. Yeah. So إذا بلشنا CBA okay, I need to choose CBA. صح؟ أنا هون بدي أطلع ED، يعني حأنزل بالA بدي أطلع ED. صح؟ okay. So إذا بدي ألحقه مثل الرسمة المعطية لإلي أنا مجبورة أمشي CBA ED, right? And here I have to do CBA ED. Okay. So يعني it is the same. We could have found one and starting from E as well in a similar fashion. So هون الباس عندنا لكينا اللي لقيناها هلا is CBA ED and the same for this one CBA ED. هلا بما إنه the inputs are interchangeable, if I am building the circuit topology, B and C are interchangeable and I can work on. Okay. Okay. So clear?
Professor, I'm just not sure how did we confirm إنه هيك بسرعة that the previous circuit إنه مجبورين نعملها 2. يعني أنا فكرت إنه بدنا نجرب كل الكومبينيشن إنه إذا بلشنا من هون أو إذا بلشنا من هون.
هلا let us look at
طلع معنا proof إنه دغري ما بيزبطش إجباري 2 in the previous circuit.
Okay, in the previous circuit it is little bit difficult to prove لأنه it is a Euler path, right? So بهاد topology, all I'm trying to say, maybe if you want to take it this way, اللي عم نحاول نقوله إنه if we give this topology a try, where A has to be at the top as an individual block, it will take maybe a long time, or maybe we will not find a proper Euler path. And the reason for this is that this block لما بدت تمرق على A، افترض أنا نزلت A B D C E، يعني على التجربة، يعني هاي trial and error معا. Okay. So in this trial and error that we have here، افترضنا أنا قررت أمشي A B C D C E C، يعني عم نجرب. اوكي. شو حيصير عندي؟ انا مجبوره نط من هيدا السيريز برانش لارجع اجي لهيدول البرانشز. صح؟ سو انا التوبولوجي بالترايل اند ايرور لإلي عم تمنعني. okay? And this, I cannot prove it now and it's a graph problem, right? But what we said that alternatively, if the same function gets represented by a different topology, then I can find a Euler path for it. واللي بين معنا هلا حتى انه انا اذا لقيت Euler path و I have the right to exchange the inputs, I can exchange them and find this Euler path. يعني اي ترانزستور جاي على البي اي ترانزستور جاي على السي. Okay, so هون صارت يعني we need to include how we approach the circuit, right? For you, of course, I'm not going to give you a problem where you cannot find the Euler path, right? Or if I give you a problem, the blocks will be a little bit smoother or easier, okay? But the idea is you are able, يعني to be able to identify the path يلي هو حيمرق بكل الترانزستors in the same order بالpull up بالpull down network. And we cannot resolve all the cases and all the problems here, but at least it was clear to you that slide 13, it was difficult to find one. And slide 14, we could more easily in a faster time identify some paths, right?
على طول بس يكون عندنا 2 topology لنفس الفانكشن إجباري يكون في Euler path.
I cannot guarantee. Okay, I don't know what circuit. Yani we can write a very complex and long circuit that no way anyone can find. And always a circuit can be interchangeable. So ساعتها هون بصير بدنا computer algorithm ليحط different possible combinations and the different possible topologies, right? So then you have to make a graph algorithm that generates the different graphs and like that. So I don't want you to generalize. All I want you to gain or keep with you in your mind from the previous slide is that sometimes I can reorder things to help myself find the Euler path faster. Okay?
Okay, thank you.
Okay, thank you. Yes.
Would path BCEDA work in this case?
Let us try it. BC.
Oh, never mind. No, it wouldn't be able to work.
Never mind. NMOS A.
Yes.
PMOS لا الإي بعيدة عنه. Okay.
Yeah. Sure. Thank you.
Okay, great. طيب. So now, let me go out. Okay, so now we have this problem or this example where we have the circuit, okay, and they're telling me that a layout is shown when I am picking, when the inputs are ordered A, E, B, D, pardon me, B, D, C. And it's clear that for this layout, it is going to be disjoint. ليش؟ لأن already A, B يعني already بالأنمس عندي A, B and then AE عفوا sorry AE and then يعني بين فارتك الأسوأ, right? So if we look at the NMOS and let's go back to the previous slide. So here he is telling me نكتبها هلا. He's telling me AE, so AE and then B and then DC. So هذا كم strip صار عندي بالأنموس؟ 3. It's clear AE, B and then DC. And then in the PMOS هون عطاني AE, so I can make it like this. So this is 2. And then B is alone. Well, I don't know how he joined B and D. I'm assuming there's something wrong here. B cannot be joined with D. B can be joined with C. Okay, so maybe even here there is some mistake in the given. بس هون هيدا it will result in diffusion breaks. فإذا هون بنسميهم diffusion breaks and you don't have to worry about this layout. Okay, and then we don't want diffusion breaks. يعني بدنا نطلع بpath لإله and redraw it. Okay, so definitely إذا أنا بدي إجي هيك I will hurt myself, but I can come back from ground, right? So I can come back from ground to visit a transistor. So what I can do, let us see if I go A, D, A, B, C, E, and let us see if I come here D, A, B, C, E, okay? So this is one example where you can use the ground node as a common node. هي بالنهاية it's a connection, right? يعني هن السيركت transistors كأنهم كلهم رايحين عند one node. Okay, and I can use it to create my path, and I'm assuming that you know how to draw the Euler path, right? Do you want us to go over the Euler path? Or is it boring?
I think Ahmad mentioned the solution.
Okay, so Ahmad أعطانا C, B, A, E, D. So let us just look at the other possible path, which is C, B. Sorry, I didn't show eraser. It's okay. It's okay. So بس slash each other. But 1 second, I need to charge the pen for a second, to take a second. Okay. So Ahmad told us that we have C, B, A, G, E. So let me see if I hear C, B, A نزل على E وطلع على D. And then here C, B, A
دي مش اي دي.
D. مظبوط. So C, B, A, D, E لف عليها و C, B, A, D. مظبوط. Okay. Okay, so this is great. So this is the solution. I will flatten and then we can follow the nodes, label them, and find what is the total capacitance. Type. I have a quick question here. What is the هيدا بالديفيوجن إذا أنا اعتمدت هو what is the capacitance at the output؟ شو حيكون capacitance على output إذا كان one continuous diffusion يعني مش disjoint or broken؟ قد إيه capacitance على output حيكون هون إذا فرضناه؟ بالP loop how many times am I visiting the output node كنود كم مرة عم نمرق عليها على الفي اوت هون؟
مرة بالبي.
once. And in the end how many times?
كمان مرة.
once. So technically I have Cn plus Cp, right? يعني إذا عندي Cn هو 2Cw وهي sorry Cp هي 2Cw and the Cn is C times W, then I can visit it once, right? So what if I had them all discretely drawn? شو كان عندها الأوتبوت نود؟ كم diffusion capacitance؟ من أي ترانزستور they come؟
بس بروفيسور what do you mean by discretely?
discretely drawn يعني أنا جيت رسمت بالبيموس حطيت ترانزستور بي هيك لحاله سي لحاله و A و D و E رسمتهم لحالهم. Okay. ونفس الشيء تحت. For what? It is connected to two PMOS, right? And two NMOS, صح؟ So حيكون عندي من ال P type B عندها one node رايحة على الأوت C عندها one node رايحة على الأوت، صح؟ ونفس الشيء من ال pull down إذا رسمت ال B لحالها وال A لحالها وال C لحالها هيكون عندي one node رايحة من على الأوت one node من ال A رايحة، صح؟ يعني this node, okay? And the other nodes coming to other places. إذا هاي 1 هاي بتكون رايحة على node 1 and so on so forth. Okay, clear? Okay, great. طيب, so لكن هلا this concludes the Euler path. هلا our plan is as follows. First, we are going to start with basic inverters. بالبيسك inverters رح ندرس نستعمل current equations to generate اللي هن long channel model to generate VOH and VOL exactly like we did in 310 and 311 the digital design, and then we are going to move from these different types of inverters the different types of logic families. يعني مش بس عندي CMOS في يكون عندي NMOS network with 1 PMOS pull up في يكون عندي dynamic logic هدول هيك nice logical functions that can be of interest to you وفينا نعتمدهم later in the sizing, so these are things that you can answer quickly and more like logical puzzles. And then we will talk about the delay and the parasitics. هلا Thursday is the last day for forming the projects. So on Friday, I'm going to briefly talk to you and introduce the literature review part of the project اللي هو حيكون على more recent topics. And for those of you who are taking 412L, we can make the 412L a more involved project. يعني بصير فيها design and literature review aspect if you're interested. And we can talk about that in office hours. So I want you, إذا بعد في حدا ما عمل group, to try to form the group, okay? And we will talk on Friday about the different topics and the literature review لحتى تبلشوا تقدروا to start working on it early حتى ما يكون عندنا آخر السمستر يعني directly we get to you in the last end of the semester when everything is overwhelming. Next week, in addition to the short quiz, we are going to have, let me just give you some timeline هيك حتى تكونوا مرتاحين. We are going to, in the week, so this Friday, I will talk to you about the literature review part. On the week of 22, okay, you will take 2 sessions during a class, all of you, لأنه Dr. Basma will be showing you, and she will be showing you the simulation part of the project, which she will initiate. It's going to be, she will give you the net list. So really all you need is to collect data. In one part, the data is collected. You just need to analyze it. And of course, it will be per group. Yani you can divide and conquer. So she will release it to you on the 24th of April. Okay, so 24th of March, عفوا. So 24 March, هنعطيكم simulation part. And in 12 March, which is Monday, we are going to release the literature review part of the project. I'm going to talk about it. The project due dates, okay, هيكون عنا, this is because we want to have 50% of the grade by requirement of the department before April 16. So we are going to have the CAT part اللي هو معظمه حتكون عطيتكم إياه دكتور بسمة due on April 13, okay, and then the literature review part due on April 26, okay. And so this way the project will be divided into 2 deliverables, and it will be released early so that you can really have time to go over it. And I will talk about its details on Friday. Okay, and what should be included, what are the topics. We will make a questionnaire online for you to select the topic, with, of course, with limited number of groups per topic. And we will talk about it in details on Friday. بس حبيت إنه to share this info with you now. Okay? So please form the groups so that we can start to build the groups حتى نعطيكم early release, and so that you can start working and accommodate for it with your time. And again, the project is 20% of the grade, so it's a good portion of the grade. There is a bonus 3% if somebody wants to present their work, if somebody feels that they need to يعني do well in the course, إذا هن حاسين حالهم they need to get some extra credit in the course. Okay, so okay, so let me I need to open the lecture notes, and okay, and let us now start with the inverter lectures, and which represents the DC part of the circuit. Okay, so let me see بس وين هاي the lecture, and 1 second. Okay, 1 moment. حدا عنده سؤال? Anybody has a question about the project or
Professor, you mentioned something about March 12 being
yes.
on Monday. Maybe you meant another date.
لحظة بس خليني أرجع الكالندر معنا. يمكن عم بقرا between different. لا Friday. هو Friday مش نحن 10. Friday is March 12. Pardon me. Friday I will talk to you about the project, the guidelines, the grading, and topics and other stuff.
Okay, but you mentioned something about literature review being released.
The literature review will be released this Friday. Okay.
بعد بكرة يعني.
بعد بكرة. and then on the week of 22nd ب 24 حنحكيكم عن الكات part، لأنه بتكون مرقتكم دكتور بسمة على 2 components اللي هن الكات 2 بالصف. She's going to do it with you in class for all of you, and cat 3 where she will tell you what portion of data will be given and the net list and stuff like that. And then you will have from 24 to 13 to work on delivering the simulation and analysis part, and في part الداتا معكم إياها. And the 26 will be deadline for the literature review for the report. Okay?
Thank you very much.
Okay, thank you. Okay, so هلا let us now move to the lecture on just 1 second, I'm trying to open it from the computer one moment. On the inverters. Okay, هلا نحن للinverters I'm going to skip the first few slides because we already studied them in the introductory lecture. يعني نحن حكينا بالintroductory lecture about we talked in the introductory lecture about the margins, the noise margins. So I'm not going to repeat that part a lot. I'm going to start يعني from where we stopped in the introductory lecture about the noise margins. Okay. Okay. So this is the. Okay. Let me share again once the lecture opens, but it is loading. Bear with me 1 minute, sorry. And I'm going to share it now. Okay. Yeah. Okay. Okay. طيب هلا basic elements. So I'm going to go over these slides very quickly. هو الانفرتر. One key thing about the inverter is that having an input, the task is to really connect the output node all the way to VDD or connect the output node all the way to ground حسب VN. Okay, so I am not connecting the input to output. وهيدي الشغلة, this we are going to repeat when we study the delay of an inverter or a complex gate. But let us now look at the analysis of the inverter as a functioning element. So ideally, for my circuit, I would really wish that if the input is between 0 and VDD over 2, the output is going to be high, and if the input is in the other range, the output is going to be low, and that the gain is 0 in all of this range, but it is infinite at this single point. هيدا بيكون ال ideal inverter characteristics. Okay, وهون بنقول إنه the logic 1 is VDD and logic 0 is 0 volts. طيب, so هيدي اسمها ال VTC, DC voltage transfer characteristic that plots V out as function of Vm. هلا inverter gain هو slow, ideally it is going to be infinite in the middle and 0 in the regions of operation. Okay. طيب, هلا in real life I cannot operate everything when 0 VDD over 2, VDD over 2 and VDD. In real life I am going to have هلا أول شيء, what happens to the inverter that for this range of input is going to map me to one value, and for this range of input it is going to map me to another value. يعني احنا عم ناخد a wide range of possibly noisy input, يعني أنا as a signal fluctuating like this, or if my signal is fluctuating like this, I'm going to map this as logic 1, and it will give me output 0, and this will be my logic 0. قد ما كانت noisy, I have the ability to reject the noise. فإذا the margins عندي هون are very high. Okay, so my noise margins are very high. Now the output voltage of the ideal inverter إذا كان ideal حيكون عنده شيء بنسميه full logic swing. شو يعني full logic swing؟ يعني as it gives me the 0 and 1 value, it is going to really be swinging between VDD and zero. يعني ال V output high لإله هو VDD و V output low هو zero, and these are the maximum and minimum achievable voltages on the chip. فإذا عندي full swing. So this term is important for us to know because some others will not have this full swing. Okay, great. So now if I look at a circuit voltage transfer characteristics in real life, the VTC of an inverter will be more like an S function but flipped, يعني inverted, a sigmoid that is inverted, and really I will have some value for VOH, not necessarily VDD, and I will have some value for VOL, not necessarily zero, okay, and I will have gain region, a high gain region and a low gain region, هون عندي low gain in those 2 points. And I will also define in those 2 low gain regions 2 points where the gain is 1. Okay, so هون عندي الgain اللي هو del V out by del Vn is equal to 1. هيدول 2 points I'm going to call them V input low and V input high. Okay, and these 2 points along with VOL and VOH مثل ما شرحنا بأول السنة in the beginning of the year are going to determine my noise margins. يعني من VOL ل VIL determines the input logic low, okay, اللي هو logic 0. Okay, so the noise margin low هو VIL minus VOL as we learned before, and then those 2 points will determine my input logic 1. Okay, and the noise margin high will be VOH minus VIH. Okay, so هيدول هن noise margins that we care about. And on top of this, we are going to define a point VM اللي بتعرفني قديش هو symmetric circuit. And this point VM is really the point at which V out equals to Vn equals to Vm. Why this matters for me? لأنه if the circuit is symmetric, this point will be VDD over 2. If it is biased, يعني if the transfer function favors output low, okay, ساعتها V out equal Vn حتكون lower. If my circuit favors output high, ساعتها it will be higher. So it will tell me really how balanced my circuit is, what it favors, and I prefer, of course, that my circuit be balanced ويعطيني favors the high output as much as it favors the low output. هلا هون هن مسميينها VS لأن it is the switching point بين الهاي واللو، يعني نعتبرها تقريبا هي ال place where the circuit is going to start to go below the 45 degree line، يعني flip from the high to the low. Okay, anybody has any questions about these basic definitions? And these are very important for our D analysis. Yes, Riwa, sorry, I saw your question now. You have posted a question about posting all the deadlines on Moodle. Yes, as I start to put out the documents, I'll put a table to post all the deadlines in the header. Okay, and the deliverables and the deadlines will also be stated in the documents that I share with you. Okay, so anybody has any questions about those basic? Okay, great.
Yes, Professor.
Yeah. Hisham.
So, the VM point is where the 45 degree line passes with the graph, or it is the point where V out equals Vn?
ما هي بالDC, it is the point where V out equals Vn. So what am I drawing? I'm drawing V out, which is Y, versus what? X. What does the 45 degree line represent to me in a graph? Y equals what? X. هلا أنا عندي الجراف هون هو V out versus what? Vn, right? So the intersection of the transfer function بيمثل النقطة محل ما y equal x صح؟ يعني intersection of the 45 degree line with the graph بيمثل النقطة محل ما y equal x محل ما v out equal vn. Clear?
Yes, yes, thank you.
Okay, thank you هشام. طيب great. So لكينا هلا أنا هو كلهم عم يشرح لنا شو هن. Okay, here he is telling me that well at v input low output بيفرق شوي. And at V input high, كمان the output is little bit different from the lowest value of the output اللي هو VR. Okay, in between those 2 points, هيدا it is a forbidden region. Sorry for the. In between those 2 points, let me duplicate the slide. حتى ما يكون عاجل هيك. Okay, so let us. Okay, so let me remove all the text. Okay, and let me go up here. Okay, so in between all of this, what we have is that the region is really forbidden. هون في عندي هيدي زي الجرافيك اللي ظبط لكم اياها. في عندي بين هيدول a forbidden region اللي هو I should not operate in. يعني my signal should not go there, and the output will not be defined. لا logic high ولا logic low. The problem is that the noise here will have high gain, يعني it is going to accumulate and it can build up. But I cannot suppress the noise anymore. So I want to operate only in the low gain regions. That's why we restrict ourselves to this signal having only this much noise margin. Okay. So this is what this slide is telling us. You don't need to worry much about it. And let us now look at noise. Why do I care about building noise margins? لأنه if my input is fluctuating then zero input low, the output will suppress the noise, and that's my goal if the gain is less than 1. Okay, so it's going to attenuate it. وهذه noise rejection property. And the single source model, I don't want you to worry about it. All it is saying إنه أنا إذا حطيت one noise, what is going to happen? And really, if I apply this one noise, I can track from the voltage transfer characteristic what is going to be, but this is too involved for you to worry about. What I want to look at هو مش a single noise. I want to look at منين إجا ال VOH وال VIH وهيدولي. إذا أنا عندي multiple noise sources, I am treating my V out as function of Vn plus V noise. If I want to use Taylor series expansion, شو بقول Taylor series expansion? بقول هو Vn plus delta X, right? Let me just look at the main equation and how it is corrected here. It is equal to Vn plus delta X. Should Taylor series, what does Taylor series tell me about a certain equation? F of X is equal to what? F of X plus delta X equal to what?
F of X can be substituted by a series of its derivatives.
Okay, F of X plus delta X times the derivative, right? Right? So this is delta X here is the noise مضروبة بالدerivative ل V out على ال Vn plus some higher order terms, صح؟ وأنا عندي ال X plus delta X. إنه if I get a noise, this is going to be multiplied by del V out by del Vn. And this is why I restrict myself. And where am I operating? Is هيدا transfer function, and I'm operating at some point اللي هي X plus delta X مش هيدا الانبوت. Okay, إذا على هيدي البوينت X plus delta X, okay, the slope del V out by del Vn is large, what is going to happen to the noise? It is going to build up and it is going to multiply as I go to the second stages. بس إذا هيدا أقل من 1 الgain in absolute value شو حيصير؟ يعني أنا my y صارت بتساوي f of Vn, okay, plus the noise times the gain. And now my y at this stage is what? The y at this point. Okay, فات النويز هون طلعت الواي عنا. لنقول I got the noise here, I got the y here. This will be the input to what? to the next stage, right? The output of one is the input to the other. طب we assume that y for stage 2 هتصير function of this input, صح؟ وفي عندها gain. What happens if I have 0.9 all squared? شو بتصير هاي across the stages?
It converges to 0.
It is going to converge to 0. معلش هاي ما شرحتها كتير منيح بس عم بعطيكم الكونسبت. What if it is 1.2 and I multiply it across the stages? شو بتصير؟ It's going to increase, right? So the concept is هالgain اللي عم يدخل هون is getting multiplied by other gains. If I am allowing myself to operate at small gains, okay, for the noise, then it will diminish. Else, if I operate in the high gain region, صحيح I can sustain to live maybe up to this point, but eventually على many stages it is going to come back and explode. Okay, so this is the basic concept. The basic concept is that we have the Taylor series expansion tells me that the gain is going to be multiplied by the noise, and since we have many stages, this noise is going to build up, and my objective, is to really go ahead and suppress the noise, so I'm going to operate only in the regions where the gain is smaller than 1. Okay, that's where we came up with the derivation of the noise margins. Okay, طب great. So لكينا هيدا عندي circuit, عندي whole points defined, and the noise margins. هلا we will have many types of inverters. We will study them one at a time. Okay, so هنبلش بالmost basic type of the inverter, which is the resistor based inverter اللي هو اللي درسناه نحن بال 310 and 311, and we will try to